So I just wanted to put together this video for mechanical engineers on a topic that's really not very difficult to understand, but many mechanical engineers that I've worked with and come across simply do not implement this technique or have never heard of it, and it causes tremendous failure in their machinery design. And the topic that I'm discussing here today are the knockdown factors by Marin. And this topic is discussed in a number of the Shigley Mechanical Engineering and Design textbooks, and it's usually in the section on fatigue analysis. And so this is what this video discussion will be about. So just to give you a little bit of history, Dr. Joseph Marin began his work around World War I, World War II, studying parts that would break in fatigue and creating charts and tables, diagrams of various parts with various materials having various failures. His theories basically consisted of 8 different types of surface conditions that added to the problem of fatigue failure, especially initiating on the surface. Now, each of these modification factors, or Marin knockdown factors, starts with a value of at least 1. So you have a multiplication effect of the endurance factors, each multiplying together with the other in order to create an overall knockdown factor that you apply to the fatigue value for the material. And the fatigue value comes from the SN curve, and I'm showing examples of each here. In some cases you may have an overall knockdown factor of an additional 50% on your fatigue allowable limit, maybe even higher. But if you're designing any kind of machine component that's under fatigue loading, you need to consider surface condition, size, load, temperature, reliability. They all have factors involved in the overall knockdown for the allowable stress of the component. Ultimately, if you read through this section in most textbooks that talk about endurance factors as related to fatigue, you'll eventually design a much better, more durable component. And typically most steel components have cycles of, say, 20 million cycles. So you have to take in consideration the maximum allowable stress that the component is subjected to during its life cycle. This is really all I wanted to discuss in this video, the importance of the endurance factors when designing a component that is going to be subjected to fatigue loading for the duration of its life cycle, and the importance of application of these factors in addition to other factors that may contribute above and beyond what's discussed by Dr. Joseph Marin. The engineer should take in consideration other endurance conditions that may add additional knockdown to the maximum allowable stress. So thank you very much. This has been Iron Designer,